This is a video from section 6.3. The directions say to use the method of cylindrical shells to find the volume generated by rotating the region bounded by the given curves about the y-axis. So in number 5, we have y equals natural log of x, y equals 0, and x equal 2. And we're going to rotate the region by those given curves about the y-axis. And so notice how y equals 0 is located along the x-axis, and that's in red right here. X equal 2 is here. And then I drew y equals natural log of x, and I just happen to know that natural log of 1 is 0. So I start at the point 1, 0, and I go to the point 2 natural log of 2. And so this is the region that we're talking about. And I'm going to rotate that region right here about the y-axis. So let's break this up into pieces, right? The height is natural log of x. So that's the height of the rectangle. The radius is the distance from the origin out to the rectangle, right? So in other words, I start at the rectangle and I go all the way out till I get to the origin for this problem, right? And so the radius is x. The thickness is dx. Now we're set. The volume is 2 pi times the integral from 1 to 2 of x times natural log of x dx. And this is a classic integration by parts problem. Remember, we have this mnemonic, L-I-A-T-E. And so this is the pecking order in which I choose my u. So my u is natural log of x. du is 1 over x dx. dv is x dx, and v is 1/2 x squared. So the volume is 2 pi times the quantity, right? It's 1/2 x squared natural log of x evaluated from 1 to 2 minus 1/2 the integral of 1 over x times x squared dx, where the limits of integration are from 1 to 2, right? So notice uv minus the integral of v du. 1 over x times x squared is just x. And we're going to go to the next line here. So if I replace x with 2, I get the following. We still have our 2 pi. It's times the quantity 1/2 2 squared natural log of 2. And then remember, natural log of 1 is 0, so basically I subtract 0. And then I go minus 1/2 the integral from 1 to 2 of x dx. And so this is 2 pi times the quantity 2 natural log of 2 minus 1/2 the integral from 1 to 2 of x dx. So this is 2 pi times the quantity 2 natural log of 2 minus 1/2 of 1/2 x squared from 1 to 2. But remember that 1/2 times 1/2 is 1/4. So this is 2 pi times 2 natural log of 2 minus 1/4 times the quantity 4 minus 1. And so finally we get 2 pi times 2 natural log of 2 minus 3 over 4. And that's how we do problem number 5. Let's take a look at problem number 9. Suppose we're given y equals square root of x, y equals 0, and x equal 4. And I want to rotate the region bounded by those curves about the y-axis. And so again, I want to use the shell method, right? So notice that y equals 0 runs along the x-axis. And so that's in blue here. X equal 4 is right here. And y equals square root of x is right here. And I'm rotating about the y-axis. And remember, I need to draw a representative rectangle. The radius is x, that's the distance from the origin out to the rectangle. The height is square root of x, because that's the square root of x curve here, right? The thickness is dx. We're almost done. So the volume is 2 pi times the integral from 0 to 4, and I'm going to take the radius, which is x, times the height, which is square root of x, dx. So this is 2 pi times the integral from 0 to 4 of x to the 3 halves dx, which is 2 pi times the quantity 2/5 x to the 5 halves evaluated from 0 to 4. And so this is 4/5 pi times 4 to the 5 halves. And so the correct answer here will be 128 pi divided by 5. And that's how we do problem number 9. If we take a look at problem number 25. Now, suppose we have y equals x cubed, okay? And we have y equal 8, x equals 0. And now what we want to do is we want to rotate about a funny axis. So in other words, we're going to rotate about x equal 3. So I have to draw a picture, okay? So here's I have my x-axis and my y-axis accordingly, right? Now, y equals x cubed looks something like this. Here's y equals 8. And remember, x equals 0 is here. All right? Now, what we want to do is we want to rotate about the line x equal 3. Well, that's right here. All right? Now, we need to draw a rectangle. We'll put that right here. We need to know the radius. The radius is the distance from the rectangle to the line x equal 3. Now, let's make sure we understand our reference. The distance from the y-axis out to the line x equal 3 is 3. The distance from the rectangle to the y-axis is x, because we're running along the x-axis. And so that's going to force us to know the radius. The radius is going to be 3 take away x. The height, well, the height is the top function minus the bottom function. So 8 minus x cubed. The thickness is dx. So the volume is going to be the integral with 2 pi on the outside, right? And we need to figure out where x cubed, y equals x cubed and y equal 8 intersect, okay? And so to do that, we'll do that over here. I'm going to set x cubed equal to 8. And so that's going to force x equal to 2. So that's x equal 2, okay? So we're going to go from 0 to 2. Now, the radius, let's look, is 3 minus x. The height is 8 minus x cubed. And we're going to integrate with respect to x. So we get 2 pi times the integral from 0 to 2 of 24 minus 3x cubed minus 8x plus x to the 4th. So I just multiplied that out. Okay? And so this is 2 pi times 24x minus 3/4 x to the 4th minus 4x squared plus 1/5 x to the 5th, evaluated from 0 to 2. So we got to plug in. If I plug 2 in for x, I get 48 minus 2 to the 4th is 16. 16 divided by 4 is 4. 4 times 3 is 12. Minus 16 plus 32 over 5. So 48 minus 28 is 20. So this is equal to 2 pi times 20 plus 32 over 5. But this is 2 pi times 100 plus 32 divided by 5. But 132 doubled is 264. So this is 264 pi divided by 5. And that's how you do problem number 25. Let's take a look at this one. Suppose I give you problem 30. All right? And we have x equals 2y squared, and then x equals y squared plus 1. And this is going to be about y equals negative 2. So this is, notice how x is in terms of y. That's probably a pretty good indication we're going to integrate with respect to y. So if I draw a picture here, we have the x-axis and y-axis accordingly. Now, we have x equals 2y squared. And I'm going to go out just a little bit, right? So when y is 0, x is 1. And I'm going to go for the other graph. Okay. And we're going to rotate that region about the line y equals negative 2. Now, here's the deal. I'm going to draw a rectangle here. If you don't mind, I'm going to draw it up here. It's easier to make the argument of what the radius is going to look like. We could make the argument when the rectangle is below, but I do think it's easier for you guys to see when the rectangle is above the x-axis. Now, this is my reference point, okay? The distance from that rectangle down to the x-axis is y. And so the distance from the x-axis to the line y equal -2 is 2. Okay? So I'm going to make the argument that the radius is y plus 2. The height, well, I'm going to take the rightmost function and I'm going to subtract off the leftmost function. So it's y squared plus 1 minus 2y squared, which is 1 minus y squared. The thickness is dx. Is dy. Now, we need to know our limits, right? Here and here. And so I need to set those two functions. And remember, they are functions because x is a function of y, right? By the way. Now, I'm going to set 2y squared equal to y squared plus 1. So y is plus or minus 1. And so my volume is 2 pi times the integral from -1 to 1 of. Now, my radius is y plus 2. My height is 1 minus y squared. And I integrate this with respect to y. And so this is 2 pi times the integral from -1 to 1 of y minus y cubed plus 2 minus 2y squared dy. And so this is 2 pi times 1/2 y squared minus 1/4 y to the 4th plus 2y minus 2/3 y cubed from -1 to 1. Okay. Now, this is 2 pi times. When I plug in 1, I get 1/2 minus 1/4 plus 2 minus 2/3. So let's double check that. Yes. Now, I'm going to go minus. When I plug in -1, I still start off with 1/2 minus 1/4. But when I replace y with -1 over here, I get -2. And if I replace y with -1 over here, I get plus 2/3. So it's minus 2 plus 2/3. So the 1/2s are going to cancel. The -1/4 are going to cancel. Okay. And this is 2 pi times. Now, 2 minus a -2 is 4. -2/3 minus 2/3 is minus 4/3. And so this is going to be 16 pi divided by 3. And okay, that's going to do it for this video. And in this video, we did section 6.3 and we did problems 5, 9, number 25, and problem number 30. So we did 4 examples. Okay, thank you.